Okay, right, slight change of tone at this point. You've heard from a couple of the generals giving the big orders and involved with the big politics. You're going down a level here to one of the foot soldiers. I was an engineer working away in, as was said, Mercury 1-1, moved across to Orange. So you'll get a more workers level view of things. I also have the advantage now that I'm no longer employed by any of the large telecom companies, so I can speak my mind on that. So also available for, as needed, jobbing consultant, Okay. So, Andy just mentioned a very important document, and it fits very nicely because Stephen was actually the author of this document, and it represents the start of what became known as the 1800 megahertz network. That's the 1-to-1 and the Orange and all that has flown from that. And it arrived in January 1989 out of the blue, a consultation document. Visionary in its time, visionary in its scope, saying well before there was what we know as the mass telecommunications, the mass mobile usage, beyond that there's more to do. We can have these portable phones, that there'll be phones for the masses, phones not designed for cars. Quite revolutionary in concept, actually. It was also saying this will be at new frequencies, above 1 gigahertz. Now that was going some, back in those days that was going some. It was clear it had to be based on technical standards, but there were 2 European technical standards. DECT was equally likely to have been the basis for what is now known as the 1800 megahertz GSM networks as GSM. Bear in mind, this was consulting on the potential of a change and an expansion before the thing you had changed and expanded had actually been rolled out successfully itself. So when I say visionary, I'm not stroking an ego, it was actually quite disruptive. And personally I'm grateful because I came into it at that time, because one of the things said there was, cellular pocket phones, no car kit, how many networks can we have, and do other people want to tender? And so way back then, and I'm afraid time has passed, I was a young engineer. I'd been employed by Thorn EMI, who were good enough to sponsor me through university, which I'm very, very grateful. And I was an apprentice, and I had worked my way into a research lab. Thorn EMI largely disappeared now. EMI Music is probably still known, but what was not known was they were a major powerhouse in their day in all things in the industry. They had brands such as Radio Rentals, Ferguson, but they also did a lot of military work, and at that time were even the owners of Inmos, the transputer people. They also had a tie-up with Ericsson, the Thorn Ericsson distribution arrangement, and the Ericsson AXE switch was one of the few switches allowed to be connected to British Telecom in those days, just in the early days of competition. This was a really big thing to have an authorized interconnect. Anyway, I was working in that lab there, and I was working away on digital radio at about 2 gigahertz, when out of the blue that consultation document came. And so I remember then writing with my colleague, Tony Wiener, a response to that saying basically, yeah, we're very up for this. As a company, we'd like a bit of this. So cast your mind back to those eras. There was no mass mobile phone business. There were, as we've seen, car phones, there were the odd yuppie phone. The latest hot things were card phones, pay phones, cards. Pre the integrated chip on the cards, these things had holograms on and little lasers that burnt things. And you had Mercury as the competitor on the street to BT with outlandishly shaped phone boxes, and Mercury was the competition at the time. Hard to remember it now, but yes, the payphone with cash was the usual thing, and the occasional card phone. So into that background came the new kid on the block, Telepoint. Now I'm not going to dwell on Telepoint because Nigel's going to talk about Telepoint later, but it's part of the story about what happened into these mobile networks. And this is an illustration from Phones on the Move, which showed Telepoint being known and mentioned and everything being done in the context of that. So Telepoint was like your super cordless telephone at home, but if you happened to be near a base station in town or in a shopping centre, you could also dock onto it and make and receive calls. And one of the things in there that they were able to do was fill in the gaps with a wide area paging and a voice messaging service. A number of companies were licensed, but the ones relevant to me, there were obviously Mercury. As we said, they had phone boxes. They were quite obviously into competing with BT. And you had BT with their own offering PhonePoint, which had a number of suppliers, including STC. And the top one, Bips, gradually ended up becoming what became Orange eventually. There was a lot of changes of shareholders, and British Aerospace sold out to a company called Hutchison Telecom, who went on to be the owners of Orange. So this was the new kid on the block. This was a service proposition that was discontinuous. Sometimes it worked, and it was slightly riven by standards and other things. But nevertheless, that was cutting edge at the time. So there we are. We responded to this consultation over a cup of coffee. And then in June '89, a sort of, this is getting a bit more serious, an invitation to run personal communication networks come out. Mercury would get one to open up the competition, and then there'd be one or two other licenses. And there was the summer gone, because we had to then sort of, got to do something, got to write something. DECT or GSM? Well, GSM has to be. And very, very far-sighted thing done was the ability to use different sorts of interconnect and a big, generous amount of spectrum to do that. At the time, it looked that way. You were going to be at high frequency, you needed a lot of cells, you were at a disadvantage of having to put that lot out. So to make it easy and reduce some of the costs, that was a really important enabler at the time to make the numbers add up. So personal communication networks, sounds obvious from the hindsight now that phones were inherently desirable and using them portable is what you wanted to do, but no, it was all about displacing the fixed line, wireless tails onto the back end of your telephone. Mercury was only interested really in switching you onto their networks, not really in thinking these things are an addition to your fixed network. It sounds crazy. Much of the marketing wasn't on create new networks with new services, it was on fixed mobile displacement and things like this. It was much misunderstood. It was an innovation in concept rather than technology, in that it was about, can you bring together new mass services aimed at the hand portable for the masses, not for the car phone type thing. You can cut the cord with service providers. You don't need airtime retailers talking to service providers, selling you phones. Anyone who lived through those days, if you had a fault, there'd be a lot of finger pointing as to who was responsible. Your dealer would say, nothing to do with me, John, you need to speak to your airtime retailer, who would say, nothing to do with John, it's your handset manufacturer, nothing to do with it. And if you phone the telephone network operator, they would say, no, you've got to deal with someone else. And the concept was also that you could innovate in service and bring these things together and actually have a one-stop shop where you buy a box, a retail experience, take it home, use it. Wow. I hope I've got my frequency bands right for the microwave, Andy, because little of that is ever mentioned, how important the microwave was to us. Of course, the disadvantages of the PCNs are also there. There were no devices above a gigahertz. When we did the costing for the handsets, one of my first pieces of work, you could buy 1800 megahertz transistors. They were made for satellite use. They were £1,000 a piece. And you think, two of them in the power amplifier. Right, £2,000 opening shot for the handset. Yeah, it'll be all right. If we place an order, it'll be doable. Oh, and the problem, you're making a change to a standard that doesn't yet exist. Slight problem. You've got no legacy revenues, so unless you get up and operational, you have no money coming in. And there'll be no one to roam to because we're the first 1800 megahertz in the network in the world, so you can't use it anywhere else. Few disadvantages. Yeah. Anyway, Unitel was formed. This is one of their pieces of glossy literature I can happily provide for the archive here. And it had concept phones, it had lovely glossy brochures. It was a consortium, US West, Thorn EMI, who I've mentioned earlier, and STC, who had been one of the suppliers into the telephone networks for very many years, disappeared into Nortel. And at that point, they had just done some of the BT Telepoint and were very interested in doing more. So there was this consortium formed, it put together a bid, a logo I don't think that you'll even find anywhere today. It was designed to look old and around forever, a bit like coach lining from the 1960s, or they're a new kid on the block. It had wonderful fancy schematics, but with revolutionary things in there, such as offloading local calls at the BSC type level. Ooh, don't think we did that for many, many years. And of course, interconnect to Mercury, Telepoint, and cellular. Telepoint, as I said, the cutting edge thing. It all went quiet. I went back to the day job, working away on something else. And then September 89, the winners are, and one of the funny things, it says the winners are Unite 1. They mistyped Unitel in the winners are, and our marketing people were mightily annoyed at the time, I remember, and they did it systematically throughout the document. It is on Stephen's website, and you can see in Unite space 1 rather than Unitel. Anyway, they were one of the winners, along with a company, Mercury PCN, which was the cable and wireless one, and Microtel, a consortium involving British Aerospace, Matra, Marconi, lots of people in it at that point. Very generous spectrum, 2 times 25 megahertz. Later in the story, Unitel, Mercury merge, and that spectrum is redistributed, but you're still looking at quite a nice tranche of spectrum. You needed to put a lot of cells in. The more spectrum you have, the easier is the repeat pattern. Later, having small cells is great because you've got the capacity, but in the early days, you've just got money to sink before you can do anything. And later, Vodafone and Cellnet got some of that, with some obligations to do something by 1999, good coverage. So, there we are, September, it all changed. Got to build a company, developer staff, innovate in sales, procure something, networks, handsets, IT infrastructure, value-added services, acquire and build some sites, build all these transmission links and switch sites, and then finally turn it on successfully. So, let's look at the network element of that. You had a number of suppliers who were credible. Motorola were already tied up in some way to MPCN. Ooh, MPCN is guaranteed a license. I think I'll go and see them. Nokia was in some way tied to Microtel. And if you ever find out how or why that happened, very early days, lost in the history of time as far as I'm aware. Anyway, they were already spoken through. So Unitel was looking around thinking, who do we look at? And we put out RFPs to the then list. Northern Telecom later, Nortel later, whatever. And because of, I think, the Thorn-Ericsson dealings, there was a bit of goodwill at high level. They were technically sort of very credible, and through the RFP responses, with a bit of judicious selection of the criteria, I'm sure, which Stephen just referred to as goes on, they were our chosen supplier. We'd love to have committed an order for them at that point. Slight problem with funding. Needed a lot of money to build all the things on that previous list, and we didn't necessarily have it at that point. However, you could get out and you could start acquiring cells, and you were aided by something called the Town and Country General Development Order 1988, which allowed you to get away with putting masts up with a little bit of slick practice, providing they were less than 15 metres. The local authority could object if they were reasonably savvy, and there were games you could play to make sure that just after they'd met, you put the application in so it might not get picked up in time for the next meeting. Never mind. Because you had a lot of cells to build, you know. And in those days, it was assumed that there would be national roaming. Almost forgotten now, but the assumption was you would build one region each. So you'd have a core region, say London, everyone would be there. But if you do Highlands and Islands, we'll do Wales. Never happened, but it was all technically built into the standard. Later, and this is a slide from Emin Gedemli at EE, formerly, back at the event celebrating, I think this was the Cellular 25. And at that point, they were just looking at supporting various networks on a common infrastructure platform. We in Unitel were busy looking at that back in those time periods I looked at, because not having any money, it was quite clear that Mercury PCN was in the same position, Unitel was in the same position, and we were trying to share revenue and share in infrastructure to reduce costs. And you know, it's amazing how the world goes around and comes around again. In the end, PNA, which was known euphemistically as probably never happened by the engineers working on it, that was never gone full speed ahead, and the companies did a full merger. So 1 year on, after we'd given Ericsson the nominal contract, they get delivered as a birthday cake, ironically, with a candle in, to say, 1 year on, you've still not placed an order. They didn't think we were ever going to do it, and were quite surprised when we did manage to get the funding together, and said, yes, have a multi-million-pound order. They said, oh God, we'd never have been so cheeky had we known at the time. But this is the sort of thing you were installing. My radio colleagues were installing radio infrastructures that were that big. That whole cabinet just did 4 transceivers with about roughly 8 time slots, give or take a few. It had to be housed indoors, couldn't go out in the cold, so all you could do was build a cabinet hoping that you'd get some infrastructure one day to put in it, whether it was Nortel or Ericsson, whatever. So people were going out designing sites, putting in big cabinets in the hope one day there'd be some radio to go in it, and eventually procuring that sort of thing. These had a half-life of about 3 years, 2 years. You can't even find any history of them or details of them anymore, gone. And they were running around building sites. This is actually slightly later photos, but you see these typical trisected sites with space diversity pointing out. And if you look at the little antennas, the little lightning conductors on the top, they're the orange ones, and if they didn't have them, the ones that look very similar to it were the one-to-one ones, very similar infrastructures. And where's Andy's moodily lit background photo of the sort of thing we're deploying in large quantities, with one of these masts coming down, and at the bottom a docking grate cabinet which was largely filled with air, waiting to get a radio in it at some point. Infrastructure colleagues were busy building things with shiny dark blue doors, if they were the Ericsson ones, and that is what a mobile switching centre looks like, cabinet after cabinet of boring electronics, full of cards with wires. And if you were the Nokia supplied, our colleagues down in Orange went with Nokia, you had grey ones with doors on. Oh, right, we've got some infrastructure, we've got some radio base stations, we've got a company, now we need some handsets. As has been said, the analogue handsets at the time were very good, much better than the digital handsets. Digital handset prototypes look like that, Ericsson has shown before. Our mission was to get phones that were no worse than the size of the analogue NEC P3. That was the marketing spec. If we could get one of them, we could launch. That was my job, get one of those. At a time when we had no standard to work from, GSM had just frozen without the 1800 megahertz variants in. That gave all sorts of issues about mutual recognition and other things, blah, blah, blah. However, we produced a Delta standard that did things like sort out the power, the channels, the class marks, how to get several hundred channels into a space in the messages that was designed for 174. Lots of different challenges involved. And we produced a thing called the Common PCN handset spec, forgotten in history, CUFS, which was the 3 operators, or the Unitel, the Mercury 121, the MPCN and Microtel, saying, right, we need some standardized stuff. Let's have on our SIMs a way for the phone to know what the phone number is, how to make the voice message thing work properly. And that actually defines where the I've got a voice message waiting indicator comes from. That turning on and turning off is buried in that spec. And then we had to find a phone, and the unlikely choice for the Mercury one-to-one phone was Siemens. And lots of people have said, why Siemens? You look on the timeline, there was nothing up to from Siemens at that point on the phones out there. You'll see the first mention of a Siemens phone was the launch phone for one-to-one. And the reason was that the Siemens P1, a transportable that could go in a car, 5 watt power class, 2 litres, and you think, well, wow, why was that your decision-making factor? Well, it existed. It was working more or less in CNETs. It was more or less being worked on to get it to work in GSM. It existed. There were chips. You could go and count this. There were boards laid out. And in there were some blocks, interface blocks, equalizer blocks, decoder blocks, coder blocks, and processors. The processor was an Infineon processor, which is Siemens' semiconductor company. And in the day, it puts its, somewhere about 286 type processor. You're really cutting edge. But revolutionary, they had a chip bringing together those blocks that I'd referred to into one chip, the Siemens Gold chip. So they had de-risked all that, and it was a simple integration task, and it was in-house, and they already had samples. And they were building it, Siemens, for that device on the right, the Siemens S1 Marathon, which looked a bit Germanic and a bit Teutonic, but nevertheless we said we'll have one of those in 1800 and we want to change the casework. And that's how we ended up with that thing on the left. That's the same bottom housing, batteries, everything else. Antenna is different because the antenna on the, how do I go up? There we go. The antenna on the Siemens S1 doesn't work when it's not pulled out. And well, that's no good. We want you to pull out. So one of the big decisions was this antenna. The other thing at the time was people really worried about emissions into the brain. And it was thought that our competitors at 900 might make stories, scare stories like we're closer to the microwave oven frequencies. So that launch antenna, which was a dog for a reason. It was a dog so that you could move the emission point way away from the head because we didn't want the fear of the network. So there's a beautifully styled version of the S1, and then it was accompanied by the wonderful Motorola products. The M100 never did surface, made by a company called NEC. It did exist, but he never got it to work to the required specification. It had a power bulge of extra chips sticking out the side, so, which I think Stephen referred to about Chinese and the Japanese suppliers not being involved in the standards, not really being able to compete at the time, a mistake they never made twice. And the odd lens on the M300 is because Mercury wanted to specify your own user interface, because shift memory recall 9 hash star to do something, which was what the Motorola interface was not going to be mass market. And in the end, and that little screen thing linked the operation in a soft key back to that button. And in the end, that IP was licensed back to Motorola. There we are. You've got a phone, you've got to make it legal. That requires building one of them, writing millions of test scripts, and if you look really hard on the shelf on the right is a mobile phone. So that lot, there's huge chapters to be said on type approval. At the day, you couldn't launch unless you had one. The system was running late. There were companies, there's a famous quote, God send mobiles. We were involved in a similar thing. We needed type approval systems, and so I got the phone, need the type approval. The Siemens phone was the S1 phone was used for the first type approval testing. So that huge transportable had an up converter with another box to make it even bigger, but it was running 1800 megahertz software. And of course you had to test the type approval system before you could test the phone, before you could use the phone against the network to get the bugs out of that, and then finally you could launch. So we did all that, and of course this was going on before GSM was really out of the way, which required me going up and down to Ericsson and Schuster and testing and integrating things with lots of problems, which I'm happy to talk about, from cells that weren't connected. I did a 999 call test without a SIM card, reset the network, which you should never be able to do from a phone, but you know. And then I did it a second time and they said, very clever, Graham, please stop it now. We had problems of handover, we had problems of thermal tracking, 1800 megahertz networks, twice the challenge to thermally track, and the phones did tend on early ones to fall off. And some of the features in the standards had not been implemented and couldn't be tested, and when they came along later, there were some nasty side effects. So it was a bloody fun. But we get to launch with Mercury 1-to-1, free off-peak local calls. That was me. I was an engineer driving down on my way to work in my battered old Nova. And I remember it to this second because Lord Young came on the radio to say we were giving away free calls at 7 o'clock, and my car swerved onto the hard shoulder because it was a superbly kept secret, so kept from the engineers who had built the network in entirely the wrong place. So in the London, it was going to be a really dense urban network for good quality business calls. At 7 o'clock in the evening, people aren't there. They're on the edges, where it was a really thin network built with omnidirectional, very skinny transceivers. And they thought this was very clever, our marketing people, and it was a triumph. And there was a huge program of rework and upgrade, because at 7 o'clock, the processor load just went through the roof. Everybody dialed. If I was expecting a call, I would make a call early, and I would leave it running, listening to a test number, so I had a channel. I could then use it. It was all about price, free, but with some really nice services in there. There were some issues with the early phones. That one on the right is when I left one-to-one, I was presented with a ceremonial broken phone on a plinth because you'll see the screen is cracked. The beautiful casework impinged in production quantities on the screens, so that there was a little bit of a pressure point and it broke. Quickly solved with a pin to keep the pressure off, but by then the damage was done. There were a lot of them out there. And the battery clip, we never did work out why it failed. They didn't fail in Germany, they failed in the UK. I think the thing is, the phone was subsidised to hell in the UK and was cheap. People didn't treat them well. In Germany, you kept it in your briefcase and never used it because it was the same part, and I'd take random ones and they would behave differently in the field. But the clip always broke off. I've got boxes of those. Forgotten history, you like forgotten history, we'll get someone to write an article on that. Mercury was trying to displace this fixed lines, so there was a thing called Carl, project name, which sat between your telephone and your fixed lines in your house to make all your fixed lines ring but then go out over your mobile. It was never deployed. One reason, it was hard to get at that point between the phones, and the other thing, it bzzed rather badly. But it was also, we didn't need to give away any more revenue at that point. It was going well, very well, thank you. And on the right, there could be the world's only photo of a Carl, which sat underneath the Motorola charger. You said, are there any skeletons in the cupboard? So there we are. And it was part of a fixed line trial where you actually had the whole thing up a masthead and worked your phones. Seems crazy, but there was no faith mobile phones were inherently desirable at the point that was being done. So that was what was happening then. In '94, I moved across, got through launch of that network, went on. I was after launch in Orange. Orange, I think, innovated in marketing and sales superbly. They'd gone with the Nokia route. My first problem was to solve all the charger pins falling out of the Nokias. And actually, again, there has been a lot of co-design of the user interface, which disappeared back into Nokia's signalling into their own IP. So it was a good co-development, that phone. Really successful phone for the launch of the Orange network. That I think might kindly mention the Orange innovations. There were quite a few. I think we were the first to do the per-second bundling, the per-second billing, the bundling of minutes, caller ID on net, before BT had it off, on the fixed network. 24-hour call return, 2-hour couriers initially if something went wrong. That was quickly changed. And a line 2 service, you could have 2 simultaneous lines on your phone. So that takes me to the end. From there it was, wow, you had the 2 networks. One was very London-centric, one was more national in its launch. Orange really spent a lot of money and rolled out very far, very early before it had any launch. And very rapidly got to the 70–80% population coverage. It took quite a lot longer for one-to-one to do that, and they were actually tied up for quite a long time re-engineering this cellular thing. So that was a lightning speed tour through, and thank you.